Let's look at how wind loading in the longitudinal direction would be resisted by a metal building. Wind in the longitudinal direction will cause pressure on the windward end wall and suction on the other three walls. The suction on the side walls and uplift pressure on the roof are not shown because they will not affect the load path in the longitudinal direction. The wind pressure is transmitted from the end wall cladding to the horizontal girts and rake beam at the top. The wind load is then carried by the girts to the columns and end posts. The load on the rake beam is transmitted to the support points at the strut purlins. Half of the loading on the columns and end post is transmitted downward directly to the foundation, and the top half is transmitted to the rake beam that is supported in the longitudinal direction by the strut purlins and eave strut, shown in blue. Remember that the strut purlins are the heavier purlins that are aligned with the anchor points of the X bracing in the roof, which is where the load is next headed. The same effect happens with suction load on the leeward wall, shown in yellow, and this loading combines with the windward wall and is the total load that the X bracing sees, shown in green. The X bracing is tension only, which means that they are slender rods or cables only designed for tension. The loads in the strut purlins are resolved into the forces that the brace in tension would carry at each intersection. The forces at the sidewall are also carried by the X bracing in tension down to the connection at the base of the column.